Roxas.
Leon. Heart.
Blast processing.
To preface this tutorial, we'll begin with the assumption that you already have an IDE like Visual Studio Code, running with all the necessary plugins and environment variables necessary to code using the SEGA Genesis Development Kit. It should go without saying, but you want an emulator or 12 to load your rom.bin file to test your code. I tend to use Kega Fusion and Blastem. Also, I recommend having a USB controller rather than using keyboard controls. Retrobit has a pretty rad USB SEGA branded controller, a 6-button controller specifically, that I use. I'm not sponsored, and I doubt that the powers that be at Retrobit are going to see this, but thanks for making a quality product. Finally, you'll likely want to look into Sprite, or if you're cheap like I am, you can try LibreSprite and use it until you're more serious about development with SGDK. Having prior knowledge of the C programming language isn't required, but it will be helpful if you have some knowledge of how to read it. Before I begin, I would like to show some helpful resources for learning SGDK in the C programming language. Okay, so this first thing we're going to look at here is the C programming language by Kernighan and Ritchie. Now, the first thing you probably want to look into is learning how to read and write the C programming language. Again, it isn't necessary for these tutorials, but if you're going to learn SGDK, you might as well read through some of the first examples in this book. Also, check out my channel, as I do have some example code written in C to reference as well. Now we're going to look at this online C compiler. So there are a few different online C compiler sites out there, but there's one I've linked to here, and it's provided by a company called Programmies. Programmies also has a free tutorial for learning the fundamentals of the C language as well, which you can see in some of the other videos on my channel. And moving on, we're going to look at the Pigsy retro game dev tutorials. So first of all, love this channel. And some of you may already be familiar with Pigsy's channel via his work on a reimagining of Castlevania Symphony of the Night on the SEGA Genesis or Mega Drive. He's British, I believe. In any event, by following along with his tutorials prior to discovering the OHSAT Games website, I developed some level of comfort coding with SGDK. I do highly recommend you check out his channel regardless, if you follow along with his SGDK tutorials or not. Those are naturally highly recommended too. And finally, we have the EikSoft code archive, and specifically we want to focus on the C language. The easiest way, in my opinion, granted it's my opinion, is to learn how to code is to read and tinkering with practice code from examples. As you'll see in my tutorials, I recommend reading the code I've written and then trying to experiment with the code. This will help you achieve a better understanding of what the code is doing and what you can and cannot modify. As you get more comfortable with SGDK, it may not be a bad idea to see if you can take some example C code on this site and port it into SGDK, and that's something that I've been attempting to do as well in my own time. With that out of the way, we'll begin looking at coding a Pong-like game in SGDK. Maybe it's more accurate to say it's a poverty-stricken individual's Arkanoid, but you can judge for yourself once you're at the end of the project. This series of tutorials will largely focus on the material provided by Andrej Preradovic, forgive the pronunciation there, of OHSAT Games. However, to make these tutorials unique, I will be providing some additional content and unsolicited cringe humor, that may reference outside sources from the tutorials my video is based upon. Please reference the notes section at the bottom of each tutorial for a more thorough breakdown of the code above. There will be a section for experimentation ideas as well. Now, we're finally going to begin the first lesson titled Drawing Graphics, Text, Tiles, and palettes.
Oh my.
You'll notice that there are two .h file types. These are references to header files that are necessary for SGDK development. You may see additional header file references as these tutorials progress, but the Genesis.h and the resources.h are all we need for this lesson. Your SGDK code, like C code, is essentially a three-legged milking stool. Actually, I'm sure there's a much better analogy than one I used. Maybe the three sections of an insect, the head, the thorax, and the abdomen. You know what? Forget the analogy. Our SGDK code is broken down into three parts, more or less. The first part is the main function. The next part is the while loop. The last part is the return carriage of 0 to close out the code. Your main focus is going to be on, well, main, but also the while loop. For those of you that may have a particular interest in coding, the first lesson you often see in many coding examples is the Hello World example. This lesson is a fancy pants version of the Hello SEGA World lesson. Rather than following the OHSAT Games lesson on how to do a makefile and all the other prerequisite work to get everything up and running, I downloaded an example tutorial from the Pigsy channel and used that to see if I could do the clean and compile commands properly. I do plan on making these tutorials downloadable so that you can modify my code, but for now, just follow along with the video and check the video summary for helpful links. For this tutorial, let's say you're using the Hello SEGA World tutorial from the Pigsy YouTube channel. Try clearing out the code so that you only have your .h files referenced, your main and while loop functions, and your return carriage of 0. The idea is to read through the OHSAT Games tutorial and try writing the code as you read through the tutorials. In this video, you'll want to read through the MEGAPONG 3 and 4 lessons. When you're done, you'll want to compare your code to what you see in the video. If you're having trouble with the IntelliSense offering suggestions, when you start to type VDP underbar, I'll make a note at the end of this video to show the .json properties. Not having the .json configured properly can be a pain, and I rarely see videos show what to do to get the IntelliSense to work properly. Now, you'll notice in my code that there is a lot of green text. This text is for writing comments about what's happening in your code for your programmer notes. It can also be used to strip out a line or lines of code without having to delete it. This is very useful, but you may not want to go overboard like I did here, as it can be very confusing with a lot of lines of code. The code I have here shows what you should have at the end of the MEGAPONG 3 and MEGAPONG 4 tutorials respectively. Yet, you'll notice that the code I commented out was the prior use code mentioned in the OHSAT tutorial to explain the concept of drawing text on the screen. First function you see is the VDP draw text function. If you scroll down to the notes section, you will see a more detailed explanation of how to fill in this function and what the parameters are. For now, just move your mouse over the VDP draw text part of the text, and you should see a window appear that explains the parameters of how to fill this function out. Try to do this with each new function you learn, and make note of the commonality between these functions. It might not make any sense now, but you will pick up things over time due to repetition. The VDP draw text function shown here is going to draw whatever text you have in parentheses at tile position 412. You can try experimenting by changing the X and Y values, or by typing a large amount of text and seeing how much of it appears on screen. It's tedious, but you can have multiple lines of text by writing out the VDP draw text function multiple times. Try incrementing the Y coordinate by 1 for each line of text you write your additional VDP draw text functions. Remember, the X and Y coordinates start in the top left hand corner. The X coordinate increasing from 0 moves to the right, and the Y coordinate increasing from 0 moves from top to bottom. Because we're moving by tile rather than by pixel, a shift in tile position equals a movement of 16 pixels. The next thing we're going to look at is the VDP load tileset function. Expanding out my RES, short for resources folder, you'll see a bunch of stuff in there, including a resources.res. You may notice a bunch of extraneous code in there, but that doesn't pertain to this lesson. That's fine. It may come in handy later. Carefully go through the OHSAT tutorial and make sure you're getting identical results each step of the way before you finally get to the point where I'm at in my code. You should see that those previous steps were commented out in my code, but are still there for reference. The purpose of introducing the VDP set tile map XY function before the function that we end up using towards the end of the tutorial is to get the coder comfortable with placing tiles on the screen. After placing a tile on the screen, the coder will notice something is off with the tile color, and thus we need to make sure that we not only define a tile set, but also a palette in our resources.res file. After loading the BG tile to form your tile set, you'll want to assign a color palette to the tile set using the pal set palette function. Hover your mouse over the pal set palette text and see what the parameters are. Check the notes section for a summary of these parameters. The OHSAT tutorial explains that there are 4 palettes of 16 colors to choose from. The OHSAT tutorial explains the reasoning for palette assignment in his tutorial, but I won't rehash it here. Just know that objects may not display properly unless a palette has been assigned to it. The last thing the tutorial wants you to do is to fill the screen with the tiles to make a more interesting background than just a solid color. Before filling the entire screen, the OHSAT tutorial will have you draw an individual tile on the screen, assign it to a plane, in this case, plane B, which is the background plane. Position said tile via tile coordinate values. Once you've seen what the lines of code that I commented out can do, you should end up being able to fill the screen using the VDP fill tile map rect function in my lesson. Those other methods used in the OHSAT tutorial aren't obsolete. They can be useful in other situations, so it never hurts to revisit old code. One thing that I find helpful is to use LibreSprite or ASprite if you're an oligarch and see if you can understand what the values 40, 30 pertain to in the VDP fill tile map rect function. Essentially, is it a reference to an 8x8 measurement or a 16 by 16 measurement? Your transparency grid will typically default to a 16 by 16 grid squares, but you can place an overlay grid of 8x8 to see if the numbers referenced in a tutorial will make sense or not. One thing that always annoyed me with the SGDK lessons I followed online was the lack of detailed explanation when referencing values. Nothing is idiot-proof for an idiot such as myself. Therefore, keeping my own stupidity and general incompetence in mind, I hope I can make this tutorial as idiot-resistant as possible. That may require separate tutorials on how to use something like LibreSprite, but for now, we'll start to wrap things up. Let's do a Control-S to save, and then do a Control-Shift-P, as in Papa, and perform a clean. And finally, we'll compile and run the ROM. Blastum is considered an incredibly accurate emulator, but I happen to like using Kega, so that's what I'll load into. Ideally, you'll be able to follow a tutorial that will allow you to compile and run without going through the tedium that I've Stockholm Syndrome myself from doing. I've had very little success with gens to do a compile and run consecutively, so I've given up on it for now, but our buddy Icon has been able to do it. Yes folks, it's true. I may reference his JSON script for his version of MEGAPONG called EikPong at another point, so you can see the modifications he has made, but that will have to wait for another time. As you can see, our text is prominently displayed with a nice tile background. As you plan your code out, it's never a bad idea to keep your backup copies of older code similar to how these tutorials are done. You can always go back and revisit your code for any notes or ideas. As you can see in my code, I made mention of trying to do a text scroll once I completed this lesson. Don't be afraid to try your hand at doing a text scroll of your own, using my codebase as a jumping off point. If you found this tutorial helpful, please don't forget to comment, like, and subscribe. Good luck on your SGDK journey, and I hope to see you soon. Thank you very much.
Yeah! All right!
For this bonus lesson, we're going to look at the OHSAT tutorial for scrolling text. I'll scroll down to the bottom to find the link to the tutorial we're going to reference. Rather than do an exact copy of this lesson, we're going to apply what we learned from the text scrolling lesson to our current code base for MEGAPONG. Pause the video if you need to and read through the tutorial. A lot of what we'll do in this lesson is to copy and paste code from the OHSAT tutorial into our code and then get to tinkering and tweaking with it. If you want to twerk too while we're tweaking and tinkering, then do so from the safety and privacy of your own home. Remember kids, safety first. We can skip the part about adding the background as we already have one. We will need a script to scroll and the code to do it. In this lesson you will see references to S16, Fix16, and Fix16 to int functions. You can hover your mouse over these terms to briefly introduce yourself to the concept of short and unassigned short numbers. For memory management purposes and value conversion, you'll learn more about these concepts later. For now, just go with the flow and pick it up later in other lessons. Looking at my code, you can see I've modified the text to script out my own Streets of Decay.
Oh my.
If you tried out the experimentation idea of adding more lines of text with the VDP draw text function, you will see that idea in practice here in this tutorial. Above the main function, you will see some Fix16 integer variables to define the X and Y offsets to be used for the plane scrolling speed. More on that later. The other integer variables we'll see are text position X and text position Y. These variables are within the body of the main function. Those are used to set the starting position on the text when it scrolls. The integer makes it so we don't have to keep fixed tile coordinates in our code. We'll see this practice used again in a future MEGAPONG tutorial. Just below this is our script that uses increments to adjust the position of each line as it's drawn on the screen. By now, we know that an increase in the Y value of a coordinate moves something down the screen and a decrement moves something up the screen. Furthermore, we have VDP set plane size and VDP set plane functions for two specific reasons. First, we need to define the boundaries of the planes we're eventually going to scroll, and two, make sure we assign our text plane specifically to BGA even though our normal VDP draw text function writes to the foreground by default. I suggest hovering your mouse over VDP set plane size to get a better understanding of the limitations on your plane sizes as well as refer to the OHSAT tutorial. Below this, it is necessary to instruct the Genesis/Mega Drive's VDP to use the scrolling modes to move our planes horizontally and vertically. To reiterate, text by default is drawn on BGA or the foreground plane. Background images are typically reserved for background B or BGB. In this lesson, we're going to scroll the text vertically and the background horizontally. We're going to define these functions later, but for now we simply need to use the VDP set scrolling mode to accomplish the aforementioned task. It's within the while function that we define which plane does what. Looking at the code, you can see I've assigned a horizontal scroll to BGB, i.e. the background, and a vertical scroll to BGA, i.e. the foreground. To control the speed at which these planes scroll, we'll try using the offset integers from the OHSAT tutorial. That tutorial uses Fix16 add and Fix16 sub in conjunction with the scroll offset integers we defined above the main function to increment the X value for the horizontal scroll and decrement the value of the vertical scroll. Unfortunately, when trying to compile using the offset integers this way, we encounter a problem. I've copied the error text from the terminal and put it into the bottom of the code for reference. I suggest reading it more thoroughly to understand what line or lines in code are being referenced, as well as to try to determine what the error handler means. Nothing is quite as satisfying as fixing a bug that has been stumping you. This one took me a bit of time for me to figure out, but pause the video and see if you can figure out what the issue is on your own. Looking at my finished code, you'll see the answer I used to resolve the compiling issue, but if you happen to notice the commented code in that section, you'll see the answer. Now that we have everything in place, let's take a look at what's going on.
Amazing.
It would appear that both planes are scrolling. It's at this point I would advise you to tinker, tweak, and even twerk to your heart's content. As you can see in this lesson, I've adjusted the values for a text position Y integer to see what would happen. After you have a few lessons under your belt, why not come back and try to add to this tutorial or carry the ideas from this lesson into another. Remember, keep at it, have fun, and game on. Cheers.